Ladies and gentlemen, good morning to all of you. I'm Dr. Yaj Medury, Director of Mahindra Ecole Central. Now, of course, we've been formally notified as Mahindra University from 20th May 2020. And I have joining me my very good friend and colleague, Professor Sreenadh, who is Institute Chair Professor and Head of the Department of Mathematics at the Indian Institute of Technology, Delhi, who has been a source of inspiration as far as we are concerned with this particular new program we're kicking off on computation and mathematics, a 4-year Btech degree. Before we get down into the nitty-gritties of the computation mathematics curriculum and what all it entails and why should one look at computation mathematics as a study option, I just thought I'll just show you a few slides on Mahindra University, because after all, we're just hardly around 2 to 3 weeks in the making. So this is one of the latest new private state universities in India, and of course, the state of Telangana's first private state university, Mahindra University, set up by the Mahindra Group, more specifically the IT arm of Mahindra Tech Mahindra. So what are we looking at? We're looking at global thinkers who will in due time become engaged leaders. Just a very brief look at why are we looking at becoming a university, one of the 1,000-odd universities spread all across India. One is that the new agenda is, of course, reimagining education, as we call it, make it more interdisciplinary, more experiential, experimental, online, looks at industry, innovation, startups, because after all, entrepreneurship is a major way forward. We will address real-world problems structured around focused research, 21st century technologies, as we call it, and the buzzword nowadays is integrate liberal arts and design. More specifically, is to look at digital humanities. That's the latest in the world of higher education, where you're applying computing to humanities, and that becomes an essence in every program which we would like to do at Mahindra University, as and when we open formally for face-to-face classes. What's our purpose? To educate future citizens for and of a better world. A mission is to train multi-skilled leaders, and we're looking at leadership, we're looking at academic excellence, and we're looking at entrepreneurial projects. All three are sort of defined in our mission as we move forward. Why Mahindra University, you may ask, and we have 5 major points. One, of course, is that we're looking at enabling professional careers and entrepreneurship, international collaborations. We are carrying through with our collaboration with Ecole Centrale France in our School of Engineering, and we'll look at developing other ones as we move forward for the other schools. Industry exposure and professional networks, and we are backed by the Mahindra Group. Startup incubation fund and accelerator, which is already existing on campus. And we're saying we would be India's first university for leveraging AI in education collaboration. And that's a major thrust area. We're trying to push artificial intelligence through everything which we do at the university. One advantage is we would be amongst India's first universities by a large industry house. You do have Reliance, you do have the Birlas, you do have the Tatas, you have Munjals, and now you have the Mahindra Group also, which, by the way, is a $20-odd billion conglomerate straddling IT, automobiles, tractors, agriculture, etc., etc. So we want to unleash the power of the Mahindra ecosystem. Just to give you an example of the ecosystem, very briefly, this is not the whole one, but alliances with the SAP, Dell, Cisco, Samsung, Intel, portfolio companies like Comviva and Pinarfina, and new age startups, Aginity, etc. Okay. One thing we wanted to actually focus on, which is going to be common for all undergraduate students, be it engineering, be it law, be it management, be it communication, be it design. What we are saying is, number one, we'll focus on communication, creativity, critical thinking, which is major as we move forward for all students. Digital humanities is included there. Okay, entrepreneurial mindset, we will teach you entrepreneurship from a very early age, as soon as you step into the campus. EI and leadership are going to be important traits, and we'll try and ensure that every student goes through AI training, data science, which sort of builds in him a sort of a computing culture to move forward. Okay, so we're taking this further, and we are saying that way back 10-15 years back, it was IQ. 15, 20 years back, actually, it was IQ. It moved forward and became SQ, social quotient for all teachers, all students. And now, very important is EQ, emotional quotient. So you're looking at the emotional intelligence aspect of every single student. Is a student aware of himself, herself? Does a student know where to stop? Does a student know how to conduct himself, herself? Okay. And what we are trying to do is take EI and combine it with AI right through, so that we're deploying technology to revolutionize the way millennials are studying. Okay, that's the way we are moving forward. Okay, and if I take it on, and the programs for academic year 2020-21, existing programs in the Mahindra Central School of Engineering, we have the four, one civil engineering, computer science engineering, electrical electronics, and mechanical, and adding new four-year courses. One is computation mathematics, which we're going to be talking about. We have electronics and computer engineering, which is looking at the hardware side, and artificial intelligence, machine learning, deep learning combined, so that students can take it forward. Okay, we have the PhD program, and on the side, I have to say that we have opened up our applications for the PhD program in engineering, sciences, humanities, and it's been very, very enthusiastic, stimulating to see the good applications which pouring in for students who want to do a PhD with us. Because after all, we're one of India's very few private campuses which are 100% faculty is PhD level. Okay, very few. Okay, of course the IITs all the time do that, but they're very, very focused. But in the private sector, if you look at campuses, you will see a mix of the Btechs, the MTechs, the bachelors, the masters, and the doctoral. But we are 100% doctoral. As we move forward, we'll try and retain that. Okay, coming down to what we're actually going to be talking about today, the 4-year Btech in Computation Mathematics. Okay. One would say, why have we started this course? And the importance is that for the last 6 years, as Mahindra Central, okay, our linkage with the Central institutes in France and the other types we've established in the US with the University of Texas at Austin, University of Florida, Georgia Tech, etc. We have become very, very strong, or relatively strong, in the areas of computing and electrical electronics. So we said, how do we build on these strengths? Okay, and one program which immediately came to mind was to look at a combination of computing and mathematics. Because if you step back, okay, and look at it 60, 70, 80 years back when Alan Turing was there, etc., it's quite known that right from the start, there's been a very curious affinity between mathematics and computing. It's perhaps no accident that Pascal and Leibniz in the 17th century, Babbage and George Boole in the 19th century, and in the 20th, because Alan Turing and John von Neumann, seminal figures in the history of computing. You can't talk about computing without removing these people from it. Were all, among their other accomplishments, mathematicians, possessing a natural affinity for symbol representation, abstraction, and logic. Okay, because as one says, while computing requires CS fundamentals as a knowledge area, the computation and mathematics focus is on maths required in different computer streams. Okay, so we have mandatory computer science courses which you'll be offering in this program. What's the basic mission of this Btech program in computation and mathematics is to equip students with the mathematical foundations required to excel in various applied and computational streams where maths plays a major role. So we're trying to produce engineers whose hands are in practice and head in theory. Okay, and that's the way to move forward. Because why maths and computing, as again we keep coming back to, is because maths gives theoretical guarantees so that computing knows its bounds. Okay, maths shows the direction, computing charts the path. Maths lets you model, computing allows you to demonstrate. Maths empowers you to propose, computing enables you to verify. Maths endorses elegance, computing sanctions efficiency. These are the sort of positives of this program. Okay, and the demand and need is absolutely intense. Demand and need is absolutely intense because you're looking at a program which is taking a base of computing and adding mathematics to it so that you're provided strong foundations in mathematics, scientific computation, and computer science. Students in this program will be encouraged to develop the skill and aptitude for innovation in several domains, such as data analysis, inference, machine learning, financial mathematics, computational biology, scientific computing, and image processing. You're looking at all these streams to assist in the process. Okay. The nature of the curriculum is designed in such a way that the program provides a perfect platform for those who seek strong mathematical and analytical knowledge blended with core computer science courses. Okay. I'm just going to take a small step here. I'm going to request my good colleague, Professor Sreenadh, who is on the line also, to sort of enhance and explain the total essence of the computation mathematics program, and then and show what's there at the IIT system. We're not going to be very far from the IIT system because, after all, the IIT-Delhi has been a pioneer leader in starting this program, which is one of the most successful ones. Please note, students, that after computer science, computation and mathematics has got the greatest choice selection from the JEE advanced students. The starting and closing scores at IIT-Delhi are incredible. I think it starts at All India JEE advanced rank of 60 or 70 and closes by 110, 120. So you're getting in students of a very, very bright nature into this program. So I'll allow Professor Sreenadh to talk about it, to explain the intricacies, the positive points, and then we can come back and answer some questions. We've designed the curriculum so that this program provides a perfect platform for those who seek strong mathematical analytical knowledge blended with the core computer science courses. Because, after all, you're going to be doing a core in CS. Okay, what would the core in CS be? It would be programming, it would be data structures, it would be algorithms, operating systems, architecture, all that part you will do. And then you're adding on with the mathematical modeling skills which you have to build so that you can go ahead and solve various problems. Okay, and because the core CS courses, what are they trying to do? They're trying to arm the student with skill set necessary for computational thinking and systems engineering capabilities. That's what is the essence. Okay, so if I look at the salient features of the program, okay, the program is designed to meet the needs of mathematics and scientific investigation and development of various other foundational techniques. Okay, that's one of the things. So you'll have around X credits of foundational maths, CS, and EE in the first few semesters. After that, you get into electives so that you can then pick up which way you want to go. And that we define it at the beginning, whether you want to do computational biology, whether you want to do data sciences, whether you want to do core, that comes through as various elective baskets which can be offered. Okay. End of the day, everybody turns around and always will ask, where are the job opportunities for a program like this? And as I pointed out, it might be a brand new program for Mahindra, but it's not a new program in the Indian higher education context. Okay, now you may ask, why don't other institutions besides the IITs offer it? One this thing could be that you require strong faculties in computing and mathematics. You cannot do with one and have a weak other department. So you need a strong department in CS and mathematics, because after all, you're offering an interdisciplinary program where the mathematicians are going to be working closely with the CS faculty and vice versa. Okay, job opportunities are abounding. Software developer, market risk analysts, financial engineering services. We are offering financial maths as an elective basket. The AI part, machine learning, computational biology. Well, after all, you're applying it to computational aspects of bio, where the mathematics, equations of flow, etc., will come in. Computational topology, quantum computing is a very strong way forward. And of course, you work in research areas where national, international labs, or you can look at academia opportunities for higher education with a master's, PhD, where you can either specialize in a very specific aspect of CS or stick to a mathematics part. Because if you look at the computing faculty in major institutions and look at the the professorial faculty have been established there for the last 15, 20, 25 years. You will see that most of them possess a very strong mathematical foundation, because after all, 20, 25, 30 years back, it was maths which then led the way to computing. And that's the way it's always been. Okay, maybe if we split up our credits at Mahindra, what are we saying? That maths and computing will form a major chunk of roughly around close to 70%, 65 to 70% of the credits. Okay, equal number splits there, and added in other basic sciences, electives, projects, the humanities courses, which sort of make up the total credit. That's why. Okay, so if I look at the number of blocks, and we have somewhere on 7 blocks, let's say, if I take 7 blocks, which will form the total courses being offered in this 4-year Btech program, you have the core computing, you have the electives in computing, you have the core computational mathematics, and you got the core mathematics and the mathematics electives, and then the science, the engineering, the physics, the chemistry, the biology, and added to that the humanities, arts, and ethics. If you sort of split this down and give you a flavor of what's being offered in this program, if you look at science and engineering, you're looking at physics, classical, quantum mechanics, the electromagnetics part, chemistry, biochemistry, and in the electrical engineering, you're looking at basics of electrical engineering, electronics part, basics of electrical engineering, circuits, logic circuits, design of circuits. You get into electronics, you're looking at the transistors, the various thyristors, the FE, this things, etc., which form the base. Okay, so you're getting a strong fundamental in the science and engineering part. Added to that will be the mathematics, and in mathematics you have engineering maths, the first 2 basic courses, which are leading on from what you have done in class 12. You're leading on from there, and then you add on the more in-depth mathematics courses, probability stats, numerical methods, real analysis, numerical methods for partial differential equations. Okay, these are all part of what you will be doing in more or less in the first 4 semesters of your program. Okay, let me just check whether Sreenadh is there or not. Okay. Okay, what would be next would be you're looking at the computing science. Okay, and as I said, you're doing programming, you're doing theory of computing, you're doing data structures, computer organization, you're doing algorithms analysis, you're doing OS, you're doing AI, the basic one. Okay, you're doing deep learning, high performance computing. All these are core cryptography, information security. All these are core courses under the computer science basket. Okay, what could be then in the computational mathematics part, where you're combining the computing science with the maths? Most of these are statistical oriented, with a little amount of financial being thrown in. Okay, so you got modeling and simulation, statistical learning, the stochastic process again, along with queuing theory, which takes up from the stats part, the financial maths, which allows you to get into more in-depth electives later on, abstract algebra, and there's Professor Sreenadh's major this thing where he said that you have to look at cryptography, blockchain technologies, and security, and that's there under abstract algebra, and of course integral equations, the variational methods, all that which you keep working on. Okay, what are the electives which at this stage we said we can offer to students of the CM department? Okay, when you're looking at data analytics, looking at mobile communication, machine learning, information retrieval, natural language processing, theory and coding, the computer networks and performance evaluation, IoT system architecture and design, which will enable you to build on what you have done in computing. These are all more ones which are mathematics application oriented. Okay, maths electives are more in-depth ones, where you move from numerical linear algebra to computational fluid dynamics to dynamical systems to integral equations to OR. Okay, so you are trying to get more in depth into the way a system gets designed using the statistical method, the stochastic method, complex analysis, and that allows you to get a flavor of the in-depth courses which can be offered. And finally, the humanities, the arts and the ethics part, where we're talking about giving you information on the economic side. We have something on the design thinking side, which gets you, which is at a very early stage in the first year, which teaches you ethics also. Then we have English communication, because after all, industry has said that any graduate in India has to have a command in the English language. Communication is a very important part. So that's communication skills. And because of our tie-up with École Centrale of France, we teach you the French language, because just in case you decide to go to France after finishing your graduation out here to do some expanded studies out there under the École Centrale link, you have to have level B specialization in France to move ahead out there. So we teach you that also. Okay, we are thinking later on to add in other foreign languages courses, Japanese and German, etc. And that we leave it to students to decide how much they want to expand into foreign languages. Of course, in today's world, it's most essential that every student has command of at least one foreign language besides our own mother tongue and English, which we do have substantial command on. Okay. What could be typical subjects offered out here? I think I've laid it out in the slides before, but just to re-emphasize that the computing and mathematics, as I pointed out earlier, is roughly around 50 credits each, out of a total of 160 credits. That's roughly around 65 to 70% gets focused on getting a student in-depth knowledge on mathematics and computer science. These are the typical courses, core courses which will be offered. Okay, and you'll see stats out there, you'll see graph theory, you'll see partial differential equations, abstract algebra, as we pointed out before, which is the cryptography, blockchain, security part. And on the computing side, you'll go from data structures to programming to computer organization to algorithms to OS to high performance computing, software engineering, etc. Okay, mostly broadly speaking, this is where we are. We are looking at getting in a very high level mathematics faculty to lead this initiative, and somebody who will be with us the next couple of years to ensure that this course gets into some depth and brings in some amount of functionality to it. But as I said, this is a course which is being offered in major IITs, be it IIT-Delhi, IIT Bombay, IIT Hyderabad close to us, IIT Kharagpur. They all have gone into computation mathematics, because nowadays one cannot think of a world where computation and mathematics don't go together. Okay. Besides looking at these aspects, what is the expected outcome which a student is supposed to possess as we move forward? Okay, as I said, number one is to understand the role of maths in computer science, to obtain a strong foundation in mathematics that is both relevant and current, and that's the vis-a-vis the courses which are going to be offered. The student is expected to apply such acquired knowledge to solve real-world computational problems, and those we bring in from the various industry internships or projects which will be make available to students. And that's why the student numbers are going to be not too high in this. Students will be able to visualize and model complex problems, and that's the important part, because when you get into the world of work, whether you are in top IT companies like, for example, Google, Adobe, Amazon, etc., all you're going to do is you're going to model complex problems which will allow them to look at things in a different perspective. Okay, to analyze and optimize hitherto constructed problems, and that's in the financial side. And you'll gain proficiency in state-of-the-art computational tools in the electives which one takes as you move forward. Okay, because as somebody said it at the start of the 21st century, separation from mathematics no longer makes any sense. Computing advances have run their course. Fundamental roadblocks are only mathematical. Payoffs are large and widespread, both for the society and maths. And I think that's where the strength of a student graduate in computation and mathematics rests. Okay, there is something solid to it. That here you have someone who's got an inbuilt knowledge of computer science and has added it on with a real solid fundamental foundation in mathematics, because after all, the base of computer science is maths, and that's the way we move forward. Okay, I apologize that so far we've not been able to sort out the audio problems which Professor Sreenadh is still facing. I hope we're able to sort it out before we finish off. Let me look at any questions which are there. Okay. I don't any questions. Okay, if there are any questions, I can sort of try and get these sorted out. Okay. One somebody which is asking, I guess, is CSC versus computational mathematics. See, I am very clear that here are two programs which rely on each other. Okay, because as a student in computer science, you will do this core courses which a student in computation and mathematics is going to do, and we pointed that out again, which is there on the screen facing you, going from programming to data structures to computer analysis, etc. Okay, it is in the other years that a student in computation mathematics moves into elective baskets. Okay, if you pick up an elective basket which is focused on the computing side, take electives in the computing side. If you decide to work more on the mathematics part, and that's why you're going to be adding on more mathematics-led electives. Okay, a computer science student, let's say, after the first 2 years, when he moves into other areas, he can actually specialize in machine learning, software engineering, in the algorithm side, in the high performance computing side, and our data structures, and take more advanced courses in those areas. Okay, that's not being cut off from the computational math student. Okay, but because of the interdisciplinary nature of courses which we offer, the flexibility is provided to students to move across. That's why. Okay, I think Dr. Sreenadh is available. Can I request you, Dr. Sreenadh, to talk a little bit on the course, the outcome, what the graduates are expected to do, etc. Ladies and gentlemen, Dr. Sreenadh.
Yes. So thank you, Professor Medury, for inviting me on this. I guess all of you can hear me now. Yes.
Yeah.
Okay. So this is a course on mathematics and computing. So the course basically starts with very strong foundations on mathematics. Say, for example, you will start with learning from the sequences and series in a calculus course, and then in the second semester you will do the something like on matrices, the very basic foundations of matrices and vector spaces, and of course the differential equations, and then move on to the third semesters on third and fourth semesters on discrete mathematics, real analysis, and linear algebra. And there are courses like numerical methods and algebra, abstract algebra, number theory. So these are the foundations of basically the applied mathematics. And for example, these days, most importantly, the cyber security and cryptography. Okay, so the abstract algebra is and number theory are very important for foundations. Actually, this is the backbone of the cyber security and cryptography, which is used in many of these security systems. Of course, there are courses like probability and statistics, which is these days it is very popular for investment banking, financial mathematics, okay, and along with differential equations. And then you have the optimization techniques and linear algebra, which is these days these are very popular for artificial intelligence and machine learning. Machine learning is basically an application of linear algebra and optimization techniques. And then you will have the courses like graph theory, and partial differential equations, computational methods for PDEs. So these are the courses which will help you. Graph theory, for example, it is used in networking and design of the algorithms. Any process that you start, any process you start in science and technology, you have to finally algorithmize it. So this graph theory actually helps one to do the algorithmic thinking, to do a thinking process in algorithmic. So in these ways, these mathematics courses are going to help you in learning the foundations of this computer science. Say, for example, theory of computing, programming and data structures. So programming and data structures is going to be very helpful for you to design any, for example, any software. Finally, you do many things and then finally algorithmize it and then give an end product. Okay, so this is what the programming and data structures will help you. And there are computer organization and algorithms. So these are all the courses of computer science. And of course, there will be data mining, which you will learn. So these things are going to be very helpful for any of your further studies in artificial intelligence or any R&D research and development in any of the companies. For example, these days, many students who are doing this program at IIT-Delhi, they're all placed in the first 2 or 3 days of the placements. And the packages are very high. And moreover, all these companies are investment banking, for example, Morgan Stanley, and Royal Bank of Scotland, RBS. Also the financial mathematics companies on the Google, Microsoft. So these are all the companies which are highly looking for the students now who has not only the computer science, but who has very strong mathematics foundations. Okay, so this is about the list of subjects and their importance in the courses like mathematics and computing. Yes, maybe next slide, please.
This more or less we are on this thing, Professor Sreenadh. The number of students always want to ask, is it better to do computer science or is it better to do computation mathematics? They're getting confused with the relevance of the course, given that CS is already there. You know? That's why.
Yeah, so this mathematics component of this computer science, mathematics and computing will help you to look at the R&D. See, the computer science and engineering mostly will prepare you to look at the computer science and engineering aspects of computer science. But when you look at anything that you want to look at the R&D, research and development of computer science, you need to have very strong foundations of mathematics, which you will not get in computer science. This computer science, IT, all this artificial intelligence, these are all the branches which actually came out of mathematics. So the computer science, you know, for example, the Y20 was there for a few years, and after that, software development was there for a few years, and then financial mathematics for a few years. Now it is artificial intelligence. But mathematics component is always permanent in all these aspects. So the computer science will be there, computer science and engineering will be there in limelight for a few years. But once if you know very good amount of mathematics, you can do any of these things at ease. Yeah, anything else that want to stress on?
Question which is being asked, I guess, is someone choosing computational mathematics, should that person be more interested in academics and research, or they can also look at getting into industry like computer science engineers do nowadays?
Yeah, so it depends on your interest. See, you have the full foundations for going into academics and research, and if you want to choose the computer science R&D, research and development, this is core of any software industry. It's not the kind of a services kind of thing, but it will be a core R&D development, research and development. Then your computer science courses that are here, that will help you.
Along with
it's like a two-edged weapon.
Yeah, it's like a two-edged weapon. I think that's most important to point out to students.
Yeah.
That all these big IT organizations with very strong R&D, they actually prefer students who have a foundation in computing science along with a very, very strong mathematics fundamental knowledge. I think
Yes.
that comes out better, that combination, than a pure CS background option.
Pure CS and engineering will only prepare you to understand the protocols which are there in the computer science and what people do in the computer science subjects. But that will not tell you what are the foundations of those computer science subjects, how those subjects are created, how those algorithms came up. So that is actually done through mathematics. So if you already have the mathematics foundations in this, then you can easily take up any research and development activity in your software industry.
What sort of project work would these students take up in their final year, for example?
Yes, many students from here, they get internships in Harvard, MIT, okay, and they take up the projects in financial mathematics, and they take up projects in artificial intelligence and machine learning, machine translations. Yeah.
Okay. So that
mostly in my experience, I have guided many students for the financial mathematics.
Okay.
Many of them got jobs in top companies in the financial mathematics companies like Morgan Stanley, RBS, all these companies. Yeah.
Okay. Okay. So this is very, it's a course which is very, very strong. I mean, a lot of student queries are always that why don't other campuses, if we leave us as IITs, why don't other campuses offer this course? We could throw some light on that.
Yeah, so this course actually is started in IIT-Delhi long back, and now this program is being started in many other IITs. Okay, so all the new IITs are going to have this program soon, and many NITs also started this program. We helped many NITs, 3-4 NITs. We helped them to design the program, and IIT Guwahati has it.
Okay.
Yeah, IIT Guwahati has this program. IIT Kharagpur has this program.
But private campuses are not starting this off so easily.
That probably because of the lack of strong mathematicians who can give a light to computer science. That could be a reason.
Okay. Yeah. Okay. Because after all, this is a maths department-led program.
Yeah, actually, the old IITs, it has been a mathematics departments, and then the computer science department was people who are doing computer science have been moved to computer science departments. But still, there are who has that common flavor. They are able to start these programs.
Okay.
Yeah.
Any other questions from any attendees? If you want to type those in the question box, then we can get Professor Sreenadh to answer them. Higher education prospects is
yes, higher education prospects are plenty. In fact, you won't get chance to go to higher education because you will be offered the pay package which is very high. And my students are getting pay package which is twice my salary. So they will never go to academics. They will never go for a PhD. Okay. Even I want them to come and do a PhD with me, but no, they are not interested.
There's one question, Professor Sreenadh. The student is asking, can a student pursue a career in aerospace after doing a Btech in computation and mathematics?
Yes, of course. There is a aerospace industry is completely about computational methods in partial differential equations. For example, the aerospace industry is about finite element methods, where you design many things and then you see how this mesh generation is working on it. Okay. So all the aerospace, there are many equations that you get. The modeling of those equations, they are all partial differential equations. And here you have a very strong foundation about linear algebra, computational methods, numerical methods, all these probability statistics, and of course optimization techniques, which comes everywhere.
So actually, we'll need students who I wouldn't say are good in mathematics for this course, but at least who have a deep interest in mathematics as the way forward.
Yeah, deep interest in mathematics.
Yeah, that's it. I think that a lot of students, you don't. I mean, people say my class 12 score in mathematics is not that great, but I always say if you are interested in mathematics as a way forward, then you would automatically do well in this course.
It's your teachers who will, it is your teachers who will sail you through all these mathematics courses.
A question on infrastructure of MEC to run this course. I think we have enough labs which are offered, because this is after all part computing, part mathematics, and more important, we one of the few campuses in India which got the NVIDIA DGX supercomputing system in case one wants to do large number crunching. There is no problem in that. We have a big, the supercomputer itself is a very small box. That's all. You won't even believe that it's something which fits into your own briefcase. But Professor Sreenadh knows that's the way computing is going forward nowadays. But we have the supercomputer so that in case there's a project in which you want to crunch large numbers, put together large data, you can easily do it out here. That's why. More important, and I think I want to stress this, is that we are delighted, we are privileged to have Professor of Mathematics of the standing of Professor Sreenadh, who's advising us, supporting us in the way forward. Okay, so he's there, and once he's there, I think students should be happy that we will have such a high-level advisor who's going to put his hand from IIT-Delhi and bless the Mahindra University program.
Yeah, I must congratulate you for starting this program. Okay, this is one of the flagship programs of IIT-Delhi. We get the students in the ranks of below 500 in the JEE Advanced. The last rank in this program is 500.
Wow. Okay.
So this is even rated higher than computer science programs in other IITs. Just comes after our computer science program, ours and IIT Bombay's computer science program. Well sought after, and many students get jobs in the Microsoft, Google. Okay. They are at par. There is no no way they are substandard or they are getting less jobs than compared to computer science. They get much more, and if you see the average pay scales are much higher than the computer science.
That should be quite appealing to all the students who are listening in, you know. That's why.
Yeah.
Ladies and gentlemen, if there are no other questions, then I would like to call it a day. Let's take this opportunity to thank Professor Sreenadh for sparing us his valuable time. Okay, and hopefully we will be able to interact with him further as we move forward. If there are any specific queries which you all have, please mail it to us at MEC, and I will get Professor Sreenadh to answer it more than myself, because after all, he's been someone who's been involved with this program for the last 8 to 10 years. Thank you very much. Thank you, Professor Sreenadh. It's our pleasure, sir.
Thank you. Yeah, thank you very much. Thank you very much, Professor.
Yeah.